So, on section 7.5, we were going to finish chapter 7 today. And the last thing we have to talk about is special types of linear systems. Now, what is the solution to a system of equations? An ordered pair. You got an x coordinate and a y coordinate. Makes a point. If you're graphing a system, what happens? The lines cross each other at that ordered pair, right? So we've done it multiple methods. We have solved by graphing and seeing where that ordered pair was. We have solved systems of equations using substitution and elimination. And then we've already graphed our systems of inequalities and talked about shaded regions. So the very last thing we have to talk about today is this section, which is kind of putting it all together. Notice the directions do not say use substitution method or use elimination method. So what it's doing in this section is it's kind of leaving it up to us as to which method we're going to use. Now, most of the time, if everything is in standard form, then we would probably want to use elimination. Okay? So if they give us an option and everything's in standard form, I would probably use elimination. So y'all look at problem A. We're going to use elimination. Tell me if y'all want to eliminate the x's or the y's. The y's. So what do I need to do to eliminate y? Bottom row times 6. Very good. Just like we did on Wednesday. So I'm going to copy the top. No changing. And what's 6 times 3x? And what's 6 times negative y? Negative 6y equals what's 6 times negative 2? Negative 12. Draw your line. And what happens? Yeah, the x's cancel and the y's. And we were just going to try about the y's. So on the whole left side of the equal sign, I get a 0. If all your variables cancel out, stick a 0 right there. Equals, then you combine your constants. So what is 24 minus 12? 12. And then you look to see if that statement is true. Does 0 equal 12? No, that's not mathematically correct. That's false. So the answer to this system is no solution. No solution. So let's talk about what in the world does that mean that there's no solution to this system of equations? Say it again. The lines do not cross each other, right? Because they've always been, we cross two lines and that ordered pair is the solution. And for every system of equation we've done, we got an ordered pair for the solution. So if we don't get an ordered pair for a solution, that means those lines never cross. What kind of lines never cross? Parallel. So these are parallel lines. You don't have to write parallel lines unless it asks you for that. If you just write no solution on your answer, that's fine with me for your homework and stuff. But y'all need to know that no solution for a system means that they are parallel lines. You just need to know that. Okay? Good deal. Let's do another one. And we should like these kind of problems because you don't even have to finish out plugging stuff in. Elimination goes really quickly. So this one says negative 9x plus 6y equals 18 and 6x minus 4y equals negative 12. So everything's in standard, so let's try to eliminate something. What do y'all want to work on, the x's or the y's? Y's. What's the smallest number that 6 and 4 both go into? 12 is a little smaller, right? 24 would work, but you're going to have bigger numbers than you need to have, right? As long as it's a number that they both go into, that'll work. But we really want to use the smallest numbers as possible. So 12. They already have opposite signs. So that's good. So what do I need to multiply times 6 to make it a positive 12? 2. And what do I need to multiply times negative 4 to make a negative 12? Positive 3. So draw my line. And I'm going to multiply the top row by 2. So 2 times negative 9x is negative 18x. 2 times 6y is positive 12y. And 2 times 18 is what? 36. And on the bottom, what's 3 times 6x? What's 3 times negative 4y? And 3 times negative 12? Negative 36. So what happens to my x's? They cancel the opposite coefficients. What happens to my y's? Also opposite coefficients. So I have 0 on that side of the equal sign. And what is 36 minus 36? 0. So now I'm left with the statement 0 equals 0. Is that true? That one is true. So does anybody know what we say if it's true? Well, since we're looking for solutions, I'm going to say infinitely many solutions. Say that again. Exactly. So if they have infinite means too many to count, right? An uncountable amount, right? It goes forever. So if the amount of solutions they have to this system of equation goes on forever, that means these lines are always touching each other because they're exactly on top of each other, also known as the same line. So if I were to get these both in slope-intercept form, guess what? It'd be exact same line. Okay? So if you have infinitely many solutions, and you do that when you get 0 equals 0. Okay? If your variables cancel out and you get 0 equals 0, it's infinitely many solutions, which means they are the same line. Okay? So if you're left with 0 equals something that's not 0, you say no solution. If 0 equals 0, you say infinitely many solutions. That's it. La 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 la. Let's look at this one. What's different about this one? They're not both in standard form, are they? The top one's in standard form. The bottom one's in slope-intercept form. And it don't really matter that it's in slope-intercept form. We just know that it's not standard, but it says y equals, right? Now, which method were we doing a lot of where it just said variable equals something? Substitution. So if it's already set up like this, I would use substitution on this one. So how do we use substitution? Right. It says y equals negative 2x minus 7. So where they have a y, I can put in a negative 2x minus 7. So that's what I'm going to do. I'm going to take the top equation, and instead of writing down the y, I'm going to write negative 2x minus 7. And technically, I could have left out that plus. And then equals 6. So negative 2x minus 7 went where the y was. So combine like terms, and what happens? So I have negative 7 equals 6. Is that true or false? It's false. So if it's false, what do you think we write? No solution. That one was very short. What kind of lines are these? Same or parallel? Parallel. Y'all understand how those canceled out? Yeah. So it doesn't have to be elimination to be a no solution. It could be a substitution problem. Or infinitely many. Let's do this one. Do we want to eliminate x's or y's, do y'all think? I say x's too. They're already opposite signs. So what do I need to multiply the top row by to eliminate my x's? Just 2. So top row times 2. 2 times negative x is what? 2 times 3y. 6y. And 2 times 9 is 18. We're keeping the bottom the same. What happens? Does anything else happen? No, you know what this means? It just means this one's not special, so you just keep solving it till you get an ordered pair. Okay? So they're going to throw your assignment. It's going to have some of them where it's an infinitely many solution, some no solution, and some where it's just regular and you work it and you get an ordered pair. All right? Got it? So 6y plus y is what? 7y equals 18 plus 10. And then we divide by 7. Y equals what? 4. And I'm going to plug that in for the second equation for y because it just looks a little simpler. 2x plus 4 equals 10. How do I solve that for x? Subtract 4 everywhere. 2x equals 6. And x equals 3. And what's the ordered pair? 3, 4. So if you don't get everything to cancel, don't freak out. Just keep on working it and get your ordered pair, right? That just means it's not special. It's normal, not special. So any questions? Would you guys please try this? Check it with somebody when you get done. I think this one have been kind of short. All right. So, y'all ready to help me out? Okay, say I want to eliminate my x's. What would I do to do that? Multiply top by 2, which gets me what? Equals 12. Do I need to multiply the bottom row by anything? Copy it. And what happens? Cancel, cancel, 0 equals 12 minus 12 equals 0. Is that true or false? What do we say if the variables cancel out and we're left with 0 equals 0? Infinitely. It is the same line. Many solutions. Raise your hand if you got infinitely many solutions. Are there any questions? All right. So y'all need to write down the following practice problems when I get there, and that is the end of this lesson.